Look at the violent force of a 1970s Saturn V rocket tearing into the sky. For decades, this was our defining image of lunar exploration. But cut to today, and the picture looks very different. We now have a pristine Orion spacecraft drifting silently through the deep black of space. Since 1972, human beings have stayed relatively close to home, orbiting just a few hundred miles above the Earth's surface. The vast expanse of deep space has sat largely empty of human crews, leaving modern spacecraft designs completely untested against the harsh realities of the lunar vacuum. Sending a crew all the way to Mars requires an enormous technological leap. Before we commit to a multi-year interplanetary voyage, we need a rigorous shakedown cruise. That is exactly what the 10-day Artemis II mission is designed to do. Along the way, this crew captured phenomena no one anticipated seeing quite like this, including a 54-minute total solar eclipse witnessed from deep space and highly unusual geological anomalies on the lunar far side. Pushing the Orion capsule to its limits meant flying further than any humans have gone in over half a century. Breaking that distance record proves that the hardware, the software, and the crew are finally ready to leave low Earth orbit behind for good. The vehicle responsible for keeping the 4 astronauts alive out here consists of 2 main pieces, the Orion crew capsule and the European service module strapped to its back, which provides the air, water, and propulsion pushing them away from Earth. To test those systems, the crew piloted this craft further into the void than any human has ever traveled, reaching a maximum distance of 252,756 miles away from home. To achieve this distance and still guarantee a safe trip home, engineers plotted a free return trajectory. This specific flight path leverages the moon's gravity to naturally slingshot the capsule back toward Earth, requiring almost no major engine burns. By stressing the service module under these extreme conditions, the mission verified that modern life support and navigation systems can reliably sustain a crew far beyond Earth's protective magnetic field. For 7 hours, that trajectory carried the astronauts over the far side of the moon, exposing them to a rugged, heavily cratered landscape that remains permanently hidden from Earth. The crew used handheld cameras equipped with 400mm telephoto lenses to document the geology below, capturing sharp, high-contrast images of the terraced edges and central peaks inside the Ohm and Vavilov craters. But looking out the window yielded details that cameras often wash out. The astronauts themselves observed distinct, unusual greenish hues scattered across the brownish lunar soil near the Aristarchus Plateau. Then, as they watched the darkened surface, the landscape was interrupted by a brief, violent flash of light. A piece of space debris had slammed into the moon. Over their observation period, the crew actively spotted up to 6 of these live meteoroid impacts as they happened. Automated probes orbiting the moon are excellent at mapping topography, but human intuition remains unmatched when it comes to noticing subtle shifts in color or reacting to sudden, unpredictable events in real time. The unique vantage point of the Orion capsule also allowed the crew to witness a total solar eclipse, lasting nearly 54 minutes, much longer than any eclipse viewed from the ground, because the moon appeared large enough to completely obscure the sun. With the sun blocked out, the surrounding stars and planets became highly visible. The crew could clearly see Venus, Mars, and Saturn glowing brightly in the dark background around the eclipsed sun. Inside the cabin, survival testing took a biological focus. The mission carried a payload known as Avatar, a clear USB-sized microfluidic device called an organ on a chip, which contains living human cells. This technology acts as a tiny, simulated human organ, allowing scientists to track exactly how deep space radiation damages living tissue outside of low Earth orbit. Physical resilience is only half the equation. Psychological health is equally crucial. To combat the profound isolation of deep space, the Artemis II crew initiated a historic 15-minute radio call to their colleagues orbiting Earth on the International Space Station. Measuring how human cells withstand cosmic radiation and understanding how crews maintain morale through simple conversation across the void provides the exact data needed to keep astronauts alive during a multi-year trip to Mars. By the time Orion swung back toward Earth, the core objectives were met. The life support hardware performed beautifully, the crew documented fresh lunar data, and the biological experiments gathered crucial radiation metrics. To mark their presence in lunar history, the astronauts formally proposed naming one of the newly mapped craters Integrity, a tribute to the spacecraft that carried them. They requested a second crater be named Carol. This was a deeply personal choice, honoring the late wife of Mission Commander Reed Wiseman. After surviving a blazing, fiery re-entry through Earth's atmosphere, the scorched Orion capsule splashed down safely in the Pacific Ocean, kept afloat by bright orange recovery bags. Artemis II verified that the mechanics, the biology, and the human spirit are aligned for deep space exploration. With this field test complete, the path is clear for the next mission to put boots back on the lunar surface, looking outward toward Mars.